Lesson 8, Estimating Quantities. Students compare and estimate quantities in the form of a single digit times a power of 10. The Federal Reserve states that the average household in January of 2013 had a $7,122 in credit card debt. About how many times greater is the national debt, which is, see, that's hundreds, thousands, millions, billions, trillions, 16,755,133,009,522. Rewrite each number to the nearest power of 10 that exceeds it, and then compare. So we're going to write it in the power of 10 that exceeds it. So that means that this one, or the household debt, is 7,122. So that is in the realm, so just the 1,000. So right above it will be the 10,000s. So it's going to be 10 to the fourth. Right now it would have 3 decimal places, so they want the one more that exceeds it, so it'd be 10 to the fourth. Here you have trillion, so 10 trillion. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this would be 13 decimal places, so they want the power of 10 that exceeds it. So we're going to have to go to 100 trillion, which is 10 to the 14th. So how many times greater than is a fancy word that means divide. And they want the national debt So about how many times greater is the national debt? So that's got to go on top. So we do 10 to the 14th divided by 10 to the 4th. So we're going to subtract the exponents to get 10 to the 10th. So the U.S. national debt is about 10 to the 10th times greater than the average household credit card debt. There are about 3 million students attending school, kindergarten through 12th grade in New York. Express this number as a single digit integer times a power of 10. So basically that just means a single digit integer power of 10. That means scientific notation. So we start here, 1, 2, 3, 4, 5, 6. So it'd be 3 times 10 to the 6th. The average number of students attending a middle school in New York is 8 times 10 to the 2nd. How many times greater, that's our divide, is the overall number of students K through 12 compared to the middle school students? So I need the students for K through 12, which is 3 times 10 to the 6th, divided by 8 times 10 squared. So we're going to break it up for the 3 divided by 8, and 10 to the 6th divided by 10 squared. So 3 divided by 8 is 0.375, and 10 to the 6 minus 2 is 10 to the 4th. Multiply that out, you get 3,750. There's about 3,750 times more students in K through 12 compared to the number of kids in middle school. A conservationist estimate of the number of stars in the universe is 6 times 10 to the 22nd. The average human can only see about 3,000 stars at night with the naked eye. How many times greater are the stars in the universe compared to the stars the human eye can actually see? So that tells us how to write our ratio. So we're going to have 6 times 10 to the 22nd divided by 3 times 10 to the 3rd. So I'm going to break it up where it's going to be 6 divided by 3 times 10 to the 22nd divided by 10 to the 3rd. So 6 divided by 3 is 2. And then we're going to subtract the exponents. 22 minus 3 is 19. So we get 2 times 10 to the 19th. So there's about 2 times 10 to the 19th more stars in the universe compared to what we can see. The estimated world population in 2011 was 7 times 10 to the 9th. Of the total population, 682 million of those people were left-handed. Approximately what percentage of the world's population is left-handed? So 682 million is close to, can round up to 700 million. So that's what we're going to do here. We're going to take the 682 million and it's around 7 million. So we have, our decimal point is here at the end. We got to go in 1, 2, 3, 4, 5, 6, 7, 8. 8 places. So they want to know approximately what percentage of the world's population is left-handed. So percentage of the world's population. So left hand over the world's population. So 7 divided by 7 is going to give me 1. And then I got to do 10 to the 8 minus 9, which is 10 to the negative 1. Now remember, I can flip that to get 1 over 10. So 1 times 1 over 10 is just 1 over 10. So about 1/10 of the world's population is left-handed, which is about 10%. The average person takes about 30,000 breaths per day. Express this number as a single-digit integer times the power of 10. So basically scientific notation, 1, 2, 3, 4. So I go in 4, so it's 3 times 10 to the 4th. The average American if the average American lives about 80 years or about 30,000 days, how many total breaths will the person take in her lifetime? So if we're doing 30,000 breaths a day, so 1 day would be 30,000, 2 days 60,000, 3 days 90,000. So we're multiplying. So I'm going to take the breaths per day and in a lifetime. We're going to multiply them. So 3 times 3 is 9. And 10 to the 4 plus 4 is 10 to the 8th. So 9 times 10 to the 8th is about 900 million breaths in a lifetime.